Welcome back to the Server Virtualization Jumpstart. I'm Simon Perryman, Microsoft Technical Evangelist, and joined again by Corey Hines, President and Lead Architect of Whole Systems.
And I'm sorry. Well, I know
Sorry for what?
Well, we ran a bit over on the last one. The problem is I love this stuff so much, I can't stop talking about it.
A lot of good content, and I mean, we had so much on storage, we didn't want to hold you guys back.
Yeah, well,
I know you're pretty passionate about storage.
Storage is my favorite thing
and
in the
SMB
world.
as well,
Yes,
right? I know we're going to hear a lot about SMB storage.
Yeah, you can stop me because we might be here till 5 talking about this thing alone, but I know we got a lot to do, so let's jump right in. So first of all, I mentioned earlier, get this thing done here. Okay, there we go. There we go. So mentioned earlier, there's a thing I'm basically in love with now, and it's called a cluster in a box.
Cluster in a box.
Cluster in a box. Now, in and of itself, it's not an entirely new concept, but if you start looking at deploying, especially Windows file server storage, right? So if you're going to deploy Hyper-V on SMB, which is Hyper-V on a file share, you better make darn sure that the file share is highly available, right? Okay. Just like if you talk to any guy that's building a cluster, you say, okay, your SAN, right? What do you tell me about your SAN? They're going to say, well, it's going to be dual controller and going to have multiple paths through multiple switches, and they're very, very passionate about the particular configuration that the SAN has to make sure that it's not going to go down, right? It shouldn't
redundancy
go down.
Everywhere.
Exactly, and so when you start looking at building a Windows file server, if you're going to run Hyper-V on that Windows file server, you've now got to have, if you do what's traditionally done, which is like fiber channel SAN, you've now got to make sure that you have that exact same level of redundancy and availability on the file server level. So you've got this kind of twin layer of uber complexity where I've got multiple HBAs going to multiple switches, going to multiple ports on the SAN, the LUNing, the zoning, all that work's got to be done. Then on the front side of the file server, I've got to make sure I've got Ethernet ports that go to different Ethernet switches that go to different Hyper-V servers, and it just becomes very complex. And so what Microsoft wanted to do was introduce this idea of a storage appliance running Windows to kind of remove some of that complexity. And I love these things. I've already bought 3 of them. I've spent over $150,000. I'm planning on buying 3 more real soon. So this is I love this stuff. But if you think about it, have a look at what typically makes up the back side and the front side of a SAN, right, of a traditional SAN. So let's relate this back to you guys that do SANs for a living. So on the back side, you got multiple physical interfaces, pools, LUNs, storage management technologies. On the front side, behind that, you've got a SAS bus, which is what's on the inside of most SANs, and then disks plugged into it, right? So 6 gig or a multiple 6 gig SAS buses, and the disks are all plugged in there. And that's what everything is. Period. And you have all these abilities to do pools, to do LUNs, to do provisioning, to do snapshot zoning, and depending on the amount of money you spend and the grade of the SAN you buy, you get all sorts of fun stuff. On the front side, you've got interfaces. Might be fiber channel, might be iSCSI, or might be SMB, for example, fiber channel over Ethernet. But this is basically what a SAN enclosure is. It's 2 controllers on the back side, a SAS bus on the inside, and a bunch of disks plugged into it, and then a piece of software that presents all the disks as logical units of storage. That's what, and you deploy more than one of these. That's what a Windows storage appliance is, right? It's a set of cluster nodes, so 2 cluster nodes in a single enclosure with a shared SAS bus and a bunch of disks and a JBOD. JBOD, just a bunch of disks. It's the coolest acronym, I think, in IT personally. So a JBOD of disks, 2 Windows Server file server nodes that have multiple Ethernet ports out the front end. So you have the exact same logical architecture of an enterprise-grade SAN without any of the complexity of having to plumb the storage in addition to the cluster nodes, typically on less power, in less use, and typically very, very simple and easy to configure.
So who actually is building all of these pieces and putting them together? Is this the OEM that's providing these? It's
an OEM-based solution, and there are companies that do this. The one we're using today is from a company called DataOn, which I bought 3 of their things recently. And we'll show you some pictures of it here in just a second, but it's essentially a 2-node cluster powered by storage spaces. So the storage spaces engine, which does tiering, deduplication, all those enterprise-grade SAN level functions, and just presents it as a 2-node file server. So when you're going to store Hyper-V, if you want to bring up another Hyper-V server, all you got to do is add it to a file share.
Now you mentioned spaces. What exactly is storage spaces?
Well, actually, we'll get to that in just briefly in a second. Want to kind of just show you what the architecture of a cluster in a box kind of looks like. So this is this block diagram kind of shows you what the logical architecture is. So you have two server nodes, typically inside the same enclosure, each one with a storage controller. The storage controller has multiple paths through local storage or through an expander port, which can go to external JBODs. You just add them as you go. We've done two configurations of these for our data center. One is 12 SSDs plus 24 or 48 external disks in two JBODs. I actually mount them back to back, so we use up less space. And then one that has 72 disks inside the single enclosure. That's a 4U enclosure. And with having a mix of SSD and spinning disk, we get to take advantage of storage tiering, which is a great new technology as well. So this is what it literally physically looks like. And this is actually one of the ones we own, two of these. We're planning on getting a couple more. If the Danon guys are listening, they're probably going, "Hey, another order." It's coming. But you can see out the back where, if you were to look at a traditional SAN, you'd probably be thinking, well, that's where the controllers slide out, and that's what they are. The nodes function as controllers. All controllers are in big enterprise SANs are little mini operating systems that control disk I/O, and that's what these things are. With the benefit of, rather than you having to run fiber channel, deal with multipath, deal with DSMs, deal with LUNs and zoning, all you do is present a file share. It's so easy. And then when you want to create a new VM that's on the new wave SAN, the cluster in a box, the new age SAN, you make it on a file share, and you're done. And I'll show you this here in a little bit because I've got this running on my demo environment. So as a comparison from traditional storage, like a fiber channel or a SCSI array, storage tiering, you get that. Data duplication, you get that. RAID resiliency groups, pooling, disk pooling, high availability, write back cache, copy offload, and snapshots. Now, a lot of the guys that are real SAN gurus, there's this my big huge SAN I paid $150,000 for. This isn't as good as that, and they're right. The really high-end enterprise SANs offer functions and features well truly above and beyond what the Windows storage appliances with cluster in a box offers, and that's fine. There's a place for those, right? But as a low-cost, highly performant, highly flexible solution for failover clustering for file servers, you really can't beat them.
Now, another advantage as well is since you're actually managing this using Windows Server itself, the underlying hardware can vary. You're not really going to have to be locked into the same OEM, the same hardware provider. You could get a cluster in a box from one organization, another from another, and have a variety of actual different back-end storage providers, yet you still manage it with a single consistent interface, still using Windows Server file services. Yeah. So give you some more flexibility with your pricing and costing model as well.
The big objection that I hear when I talk to people about this is they go, well, it's a two-node cluster. I want to add a third node. And okay, you can't add a third node if it's a two-node cluster in a box. But that's just a trade-off you have to decide to make. If you use, for example, a traditional SAN, you want to add a third and fourth node, you can. With these, they're fixed, but they're not. There's not just two-node cluster in a box. There's some companies make 4 nodes.
16 larger. Yep.
So, it's just a matter of kind of planning in advance. But you're right. Like when you buy a SAN, you can't choose to add a third controller to it. This kind of operates in the same methodology. One of the things that's new for Windows Server 2012 R2, we're not going to spend a lot of time on this because this is not a virtualization technology per se. And I know there was a jumpstart recorded a couple of weeks ago that focused on storage. So you want to find the link and post
that on the Microsoft Virtual Academy. Yep.
You'll be able to kind of get more detail on this. And I also know that Rick and I did this in our jumpstart a number of months ago. We showed some demos of storage tiering. But essentially, you can have some solid-state drives, so some expensive, fast SSDs, and some less expensive, not as fast hard drives. And the ratio that a lot of people have kind of settled on these, 10% to 90%. So 10% SSD, 90% spinning disk. And what the storage tiering will do is automatically move hot data to SSD and leave cool data on hard drive. So you get the performance of SSD for the data that you hit most often. And it's done at a block level, not a file level. So literally, if you have a VM, part of the VM could be on the SSDs and the rest could be on hard drive. So if you got a VM that's running SQL, for example, it might work out that the blocks containing the SQL transaction logs need to be on SSD. And you get the benefit of SSD speed for SQL transactions without needing all the SSD space for the entire operating system, including the stuff you wouldn't necessarily need. You can pin files which means you can force certain files in their entirety to be on a certain tier.
You know, conceptually, I kind of think of tiering as almost like memory, you know, on an actual server. So the things you need to access faster, those get cached in local memory. Quick access, the stuff you don't need gets stored on the actual hard drive. So you could kind of think of it as a similar concept of that.
For those of you that are, you know, really geeky and technical, the tiering, the evaluation as to what should be on SSD versus hard drive is done once a day at 1 a.m. and it's a scheduled task using the task scheduler, so you can change that. Right? You can go in and say, well, I want to do it 4 times a day or twice an hour. It's up to you, depending on how often you think the hotness of data will change. Right? So you can adjust that, and you can also force it with either PowerShell, or you can also force it with the old defrag command, are the 2 ways that it actually does it. And both those tools can report how effective that's actually being. So.
Now, we mentioned storage spaces a few times. Let's go into some more depth here.
Okay, sure. Actually, let's go have a look at a demo real quick. There we go. So what I've got here, if you want to kind of take a quick look, this is a scale-out file server. We're not going to get too much into the file server component of this, but let me grab failover cluster manager and just connect to this. So what I've got here is a cluster in a box. This is one of the data on units that was actually in the photograph in the slide a few slides ago. And I've set up a file server that's got a file server role, which is running a scale-out file server, which is a new type of file server. This isn't your traditional Windows file server. This is a scale-out file. It's a new kind of file server. And it's got some shares that are running. And there's a share here called VMs, where I'm actually can run VMs from. And to kind of give you a very deliberate example of what I'm doing here, this Win client VM that's over here on this first node is actually running off that scale-out file server. So you can see here in the path, the VHD for this VM is running on the scale-out file server. Not the actual VM itself. The VM itself is still on the local storage of the cluster, but the VHD is actually over on the scale-out file server. And so this scale-out file server, for its storage, uses a storage pool using storage spaces. You can see that it's got some virtual disks and it's got some physical disks. And you can see the status of each physical disk, slot number, enclosure number, bus type, and all sorts of information on it. So this is the type of thing that if you're a SAN administrator, you're used to seeing in the UI for your SAN. So if you go into, if you use like a Dell SAN or an HP SAN or EMC or XIL or any of those, when you go in there, this is the type of stuff you see. Disks, pools, allocations. And then within Server Manager is where you actually get to administer all these storage pools. So we got a storage pool area that shows physical disks. And this exposes things like, on the physical disks, toggle drive light. Right? So if you have one that, for example, reports as failed, you go, well, which one is that? You can toggle the drive light and replace the failed drive. Creating storage space is just, I've already got this done, so I can't do it again, but it's just a matter of running through a simple wizard, picking the physical disks, and away you go. When you go to create a virtual disk, and again, we're not trying to get too much into this, but you can do what's called thin or standard provisioning. Thin provisioning allows you to define more space than you actually have and add it later, which is a traditional SAN function. If I go new virtual disk, choose the storage pool, give it a name, let's call this one test, and because it's identified that there's a combination of SSDs and hard drives in here, I can do create storage tiers. It'll say, all right, what type, simple or mirror? So we'll do a mirror so it's replicated and protected. We'll do a two-way mirror, and then it go, all right, how much hard drive space do you want and how much SSD space do you want? And I've got very little available because I've used most of what's on here, so I've got just like a couple of gigs left. So we'll go specify maximum size for each of these. Finish the wizard.
Now, you did mention that this tiering is only available on 2012 R2, but Spaces is available on 2012 and 2012 R2.
And 2012 R2.
So you could get some questions, actually asking you about what has come out on the latest version. So as far as the storage capabilities go, Spaces is 2012 RTM. tiering, and what we're going to be talking about, tiering is 2012 R2. And the other thing we're going to be talking about shortly is data deduplication. That was also available on the older version, 2012 RTM as well. So really, tiering is the only new one that's unique to 2012 R2.
So moving on to disk duplication. This is something that was introduced with 2012. It's gotten better in 2012 R2. It essentially allows you to take a bunch of disks on a drive, it's not compression, right? The net result is kind of the same, where you put 100 gigs on a drive and you run this and you go, now I got 10 gigs on a drive. Compression does that, but what compression does is removes white space in files. What this does, it looks at it, says, okay, you have this 4 times on the disk, we're going to store it once and record pointers to it. So it eliminates duplicates at the block level, which means it's incredibly efficient on VHD libraries. If you think about it, VHD is an operating system. You got 200 VHDs in a folder. That's 200 copies of the Windows operating system. Think of the duplication. I did a test with one of our archive drives. So we take all these lab VMs and we archive them off just once they're all up and running. We put them on an archive drive, put them on a shelf in case the SAN dies and we got to pull them out again. And we're burning through 50, 60, 80 terabytes of drives on these 2, 3, and 4 terabyte USB drives. Run disk duplication on it, or deduplication on it, and went and got upwards of 98% of the space back.
Well, and that's because so many of them are just Windows
identical.
Server.
It's Windows Server, Windows
With
Server,
something
Windows
on
Server.
top, tiny bit on top.
And they're so identical that 98% compression. That's not the right technical term, but that's sort of the net result of it. With R2, it now supports running VMs. So phenomenal in VDI scenarios. Because if you can run deduplication and you can take all your VHDs and get them down to a smaller disk footprint, that's more of the actual data that could be in RAM cache, which means it'll run faster. Which means more
performance benefits as well as storage
can live
benefits.
on the storage tier and the SSD tier. So the result is the coverage you have is much better. So the performance is much better.
Now, one other catch you could see on the exam is R2 also added support for cluster shared volumes, or basically virtual machines that live on shared cluster disks. So if you have a question around troubleshooting, deduplication doesn't appear to actually be saving you any space, make sure you check what version you're running, because deduplication will only work on the CSV on 2012 R2.
And I don't know the answer to this, but parity is or is not supported on cluster shared volumes for deduplication.
Oh, good question. We'll have to ask our team of experts to go look into that one.
There's something about, there's a support, experts figure that out and post up the answer. I know there's a difference there somewhere, but I don't remember what it is off the top of my head. And then finally, offloaded data transfer. This is, so this is not something that's on Cluster in a Box. This is traditional fiber channel, high-end SAN, where if you want to move a file from one server to another and they're both live on the same SAN, even though they're on different LUNs, traditionally what you have to do is actually move the file through one server, over the network, into the other server, back onto the same SAN. It might actually land on the same physical disk. That's, in theory, dumb.
Network traffic as well, right?
Yeah, so what ODX allows you to do is say, hey, SAN, move this file to here and reassociate it. And it'll actually, the file will never leave the SAN, and the move is almost instantaneous.
It's, often redirecting pointers, not even copying data in a lot of cases.
So, it looks like the file copy happened, but instantly.
Now, could you use this for, say, VM deployment? You want to go deploy a lot of VMs.
I don't know. Could you?
Absolutely.
All right. Excellent.
Do much faster VM deployment because you're basically starting with a VM on a storage array. Say, I need to clone this 50 times.
Yep.
Could be much faster because you're not actually copying that, one 10 gigabyte file to a different location. You're essentially keeping it within the same storage.
Can you think of any service that copies VM files really, really, really fast? I can think of one. So finally, SMB3, we mentioned this earlier, huge improvement, right? And so if you look at this list of features that are added in SMB for R2, this is all the stuff that you would traditionally find in a SAN, okay? Transparent failover, meaning if I got 2 cluster nodes and I'm running, and this is one of the differences with a scale-out file server. So I've got a VM that's running off cluster node 1, and cluster node 1 goes down. Now, in the past, VM's going to blue screen, storage went away. With this, it doesn't. It just fails over to node 2 automatically because it maintains a primary channel on the first node, and then through a program called SMB Witness, it has an alternate node that it can flick over to immediately. So if the node goes down, it just falls over, which is what multi-channel is. Which is what you get when you have multi-channel with transparent failover. You have scale-out, which means you can add additional nodes, and it will automatically start to use them. So in the past with traditional file server clusters, the file server lived on one node and the other node was idle. So all the traffic was here.
Active, passive.
Exactly. This is active, active. So all nodes will automatically balance everything. SMB Direct we talk about, there's additional SMB encryption, and there's now a volume shadow copy provider for SMB shares to make sure that if you're doing backups over shares, they can be consistent by taking the snapshot and rolling ahead transaction logs, things of that nature, and then it's all supported via PowerShell. This has to work on both sides. It is not backward portable to 2008. It's 2012 and later only. And then finally, because of all that, you can now run VMs over SMB. That's the end of the day. That's the goal for all this. Is that Hyper-V, almost better than direct attached storage or SAN or iSCSI. It's almost better on SMB because it's much simpler, easy to configure. All the stuff you need is fully supported if you put the right infrastructure in place, and you're basically good to go.
A lot of diverse OEMs as well. Yep,
absolutely.
Using that single consistent management framework.
Absolutely. So.
All right, well, we've gone and we've wrapped up kind of our host deployment steps, really talking about how we set up our infrastructure, do some planning and best practices. Now we're going to move on and actually look at deploying our virtual machines and managing those VMs on our applications. So what are we covering in this module, Corey?
So essentially, this is your, how do you administer Hyper-V from the standpoint of just, without VMM, how to just do basic admin tasks. Hard disks, virtual machines, types of hard disks, installing and importing virtual machine checkpoints, and some monitoring. And we're going to try to take this to a little bit of a more technical, a deeper technical level than what the bullets would imply, and kind of sort of teach you the best practices, the things that are maybe not so obvious. For most people, creating a VM is, it's run through a wizard. It's pretty straightforward, but there's some things you got to be aware of and think about to make sure that when you do it, you don't put yourself, in a bad situation or, kind of paint yourself into a corner, so to speak. So the first lesson that we deal with is VHDs. So first of all, essentially what is a VHD, right? VHD is basically a file format. You don't need VMs to use VHDs. They're supported natively in the Windows operating system. You can use Disk Manager to create a VHD. You can use PowerShell to create a VHD. It doesn't have to contain an operating system. I've had people use VHDs like a zip file. It's a container file format that VMs happen to use. And it comes in different formats and styles and whatnot. When you attach VMs, again, it's the hard disk that a VM is going to use. There's two ways you can do it, IDE or SCSI, so they support both formats. With IDE, it's the limited, maximum 4 disks IDE implementation that's been around for eons. Or you can do SCSI, where you have multiple SCSI controllers, lots of disks per SCSI controller for VMs that have, many, what would appear to be directly attached hard drives. They mentioned Gen 1, Gen 2 VMs in here. We'll get to that in just a second. That's a new thing for R2. So in terms of formats, there's 2 formats you'll bump into, VHD, VHDX. VHDX is the newer format, bigger, badder, faster, better. Right? That's kind of all you need to know. 64 terabytes in size, much more consistent in terms of failure. It's the default format. You can convert from one to the other as long as your VHDX isn't so big it can't become a VHD. And then if you're going to upload to Azure, you want to use VHD formats. You can, and there's a convert command with PowerShell, or within the UI for Hyper-V. So you can cancel here real quick.
And for our VMware administrators out there, that'd be equivalent to a VMDK file. Again, just the hard drive that's used by our virtual machines.
You can actually come in here under Edit Disk, point it at any VHD or VHDX file, and do things like convert it, shrink it, make it smaller, change the format
inspect
types,
it,
make sure it's valid.
Yep.
So it's all there, and it's all real simple, real straightforward to use. There are 2 basic types of hard disks. There's fixed and dynamically expanding. Think of these as reserved space versus use it as you need it. In the past, there was a performance difference. Today, there's really not, but there are some things you want to think about. With a fixed size, if you create a 2 terabyte fixed size VHD, you're going to wait a little while because it's going to go in and write 2 terabytes of data to your disk. And so depending on how fast your storage is, creating that disk might take seconds, minutes, hours.
But you might not even be using that full 2 terabytes, right?
Correct. But you have a 2 terabyte disk. With a dynamically expanding, it's instantly created, and the file will grow physically as you add things to it. The downside is it can become fragmented, and you can overcommit your storage. So you've got to plan it accordingly. If you're looking at, I'm going to put, I've got 2 terabytes of storage, and I'm going to put a bunch of stuff on here, and you start adding things to those VMs, it can fill and saturate your storage. So it's something you've got to plan and monitor. I tend to rely on dynamically expanding 99.9% of the time because I monitor storage. I know when I need to make it bigger. I know when I need to be concerned on things. Then periodically we'll defragment stuff during maintenance windows just to get it all nice and clean. But the benefit is I get to provision more than I effectively have and use what I need.
Now, exam question you might see is if you troubleshooted a Hyper-V host and the virtual machines stop, what is a good thing to check? Or check it to make sure that they have additional disk space is one of going to be those best practices. Because if you are using this dynamically expanding disks, you are over provisioned and you run out of space to write, this will cause your virtual machines to shut down. So a good troubleshooted step to check for that, but an even better best practice is implement monitoring so you can detect this ahead of time.
Yeah.
We'll cover that one soon.
So differencing disks, again, they're pretty standard across all virtualization platforms. Essentially what it allows you to do is create a parent disk, and then a differencing disk is effectively a clone, but that doesn't contain any data. And if you look at the little graphic here, as you read data, it's read from the parent. As you write, the writes are intercepted and dropped in the differencing disk. So over time, the differencing disk will grow as you modify it, and eventually, it'll become equal to or greater than the parent. Differencing disks are not generally recommended for any kind of production scenario, except for VDI, right? With VDI, you often will redeploy the VMs, and differencing disks are a good way to do this. In fact, the wizards that come with, I know with VMware, I know with Citrix, and I know with Microsoft, all leverage differencing disks as part of their VDI deployment as a way to quick deploy VMs. So I start with a base image that contains an operating system, rather than deploying the operating system over and over and over and over again. You make differencing disks of it. The only thing you got to make sure is that, if you're doing this, as soon as you make a differencing disk, if you modify the base in any way, shape, or form, the diff is corrupt.
Good best practice.
And I've seen people, that are not familiar with this, create a VM, create a base disk, create a bunch of differencing disks off of that base, and then, I want to put some patches in there. So they go install the patches in the base and think it's going to mirror up. You've just corrupted everything by doing that. Mm-hmm. So as soon as you make a differencing disk, the base is off limits forevermore. If you delete the differencing disk, fine, go edit the base. But if a diff exists that's linked to a base, the base is off limits. If you modify it, you corrupt the diff. That's simple. You can use direct attached storage for Hyper-V. So instead of VHD files, you can directly attach hard drives to VMs. And this is done it's pretty straightforward. If you go into a VM, you look at the settings on it, and you come down here under the storage area, and I want to add a hard drive, you can see that I can actually go pick a physical disk. And what that will do is map the physical disk directly into the VM. So why would you want to do this? Well, there's a lot of reasons. There are some we talked about in the beginning with virtualization. Maybe your vendor doesn't support their app in a VHD, so they require it be on a native drive. Maybe you're doing, there's some performance element or some file format they want to use that requires a native drive. It's also a good way to get, if you have a hard drive that you want to, full of data you want to get into a VM, you're going to directly attach the hard drive. So there's reasons you might want to do this. From a performance angle, there are scenarios where, SAN performance, native SAN performance might be better than VHD, and you want to directly attach the SAN disk to the VM. This is what allows you to do that scenario. So you can directly attach a hard drive if you need to. If you do direct attached, you don't get to do things like checkpoints. You don't get to do things like live migrations and exports. So you're bound to that physical machine. So you lose a lot of the benefit of virtualizing when you go to a directly mapped hard drive. There's a new capability that's been added for R2, and this is one that you want to spend a little bit of time on. when you're looking at preparing for an exam and studying and whatnot, which is virtual hard disk sharing and QoS. So these are two brand new things for Hyper-V R2, and let me kind of explain briefly what they are. So if I take a VM here and look at the settings, and I take a hard drive and just kind of expand my way down through into this advanced features area, I have an area called Enable QoS. Now, what this does is limits the IOPS that Hyper-V will allow a particular VM to write to a VHD. So this is something that I know folks have wanted in Hyper-V for a couple of versions now. The ability to not have a single VM that's consuming all available disk I/O.
Because that could negatively impact everything else on that host, right?
Absolutely.
They'd be starved for their own disk I/O.
And so folks are well and truly used to the guys, talk to the guys that do your firewall, right? They've got QoS policies on what you can FTP, what you can stream for media, how much you can put on Facebook, to prevent any one protocol or method or whatever from saturating the entire line. You can do the same thing now with storage. You can do this with networking. So this is, on the network adapters, this has been in there for a while, where you can actually go in and configure somewhere in here, there you go, network bandwidth management. But it's now been added as well to the VHDs themselves. So you can come in here and say, for example, 100 IOPS is all it allows to do. It does an 8K increment. Now, the 8K is relatively important because if your underlying disk system uses 4K IOs or 16K IOs, you've got to factor that into what this is. So for example, if you're looking at your underlying storage and saying, I wanted to limit it to 200 IOPS on my SAN, but my SAN does 4K IOPS, you would put 100 in here, right? Because this is twice as big. Likewise, if your SAN did 16K IOPS, you might put 50 in here. You might put put 400 in here because you got to do the math on it, basically. So pay attention to that. Know that this is an 8K IOP, and know that if you've got a SAN that does a different level of IOP, you may have to configure this a little bit differently.
Now, minimum bandwidth for networking and minimum IOPS for storage. This guarantees that particular VM always gets at least that much, right?
Correct. And if not, it's going to generate warnings, right? So if it cannot satisfy the minimums, you're going to see warnings appear in the event logs. It doesn't guarantee it per se because it might not be possible, but it will tell you. It will tell you that, hey, you don't have enough to meet your minimums. And then the max is how you would limit something entirely. So that huge SharePoint VM that's consuming all your disk I/O, you come in and say, you know what, no more than 200 IOPS, you're good to go. And so it has that effect of leveling out the hills and valleys of everything. And then the other one is, as I said, shared VHDX. So this is a huge item for hosters, right? So if we go back to this scenario of guest clustering.
And again, that's the VMs that have an application running within them, right?
Correct. So guest clustering. I have, let's say, a scenario of SQL Server. Okay, so I have two Hyper-V hosts, and on one Hyper-V host I have SQL Server Node 1. On the second Hyper-V host I have SQL Server Node 2. If I want to cluster those, right? Because remember, if with live migration and quick migration and failover within VMs, if the host goes down, the VMs power off, transfer over, and power on again. That's downtime, right? That's maybe minutes or seconds or whatever.
For an unplanned failure.
That's for an unplanned failover. By doing active guest clustering, if that node goes down, the application can just fail to the other, can automatically fail to the other application that's running on the other node. To accomplish that, you've got to get shared storage to your VMs. Now, there was only one way to do this in Server 2012 and Server 2008, which was iSCSI. And people just went,
Now, why? Is that because iSCSI performance isn't optimal if you're trying to run SQL?
iSCSI performance is never as good as something like Fibre Channel because it's got the overhead of TCP/IP. There's all kinds of people that claim it's good and better, and certainly there are good implementations of it. But iSCSI is it's not something that I'm personally a fan of. For big production systems, I prefer things like Fibre Channel. So you can kind of do two things. One, you can attach Fibre Channel directly to a VM now, which we'll get to later on. But you can actually define a VHD as being shared between two VMs. And by having the two VMs share the same VHD, you get shared storage inside the VMs. Now, there's some requirements for this, and one of them is the shared VHD has to live on a scale-out file server. So you're back to this Hyper-V over SMB scenario. where the both SQL instances live on a scale-out file server. They're clustered under Hyper-V at this level. Up here, they're on a scale-out file server. There's a shared VHD on the same scale-out file server, so that becomes their shared storage. And it's much, much easier to implement and manage at the fabric level than having to, attach iSCSI, which requires network connectivity, or Fiber Channel, which requires physical cable and fiber connectivity.
And I think another nice advantage for our hosters as well is it kind of provides a layer of abstraction for security. So you don't actually have to expose that underlying storage fabric. You can just say, here's your file, here's the path of your file, go connect to that, and now you can go build a guest cluster.
And the implementation is literally a piece of cake. All you do is you add a VHD to a machine, you point the VHD at a file share, and you come in and check this box called Enable Virtual Hard Disk Sharing, and just point 2 VMs at the same file. And they'll both see it as shared storage, just like an iSCSI LUN or a Fiber LUN or anything else. So it's the simplest way to accomplish it if you're running in a Hyper-V over SMB implementation. So that's that. So that's kind of some of the storage considerations for what you can do within the VMs themselves. There's a lot there. There's a lot you can do. There's a lot to think about. So let's move on and look at creating and configuring some virtual machines. So first of all, there's 2 types of VMs, Generation 1, Generation 2. I'm just kind of flicking back and forth there between the 2 slides. Generation 1 VMs are your traditional VMs. They're based on the spec of what is a PC from circa 1921, I think, which is a couple of IDE controllers, a BIOS, CD-ROM drive, a 100 meg network card. So it's what we all traditionally thought of as a PC back, in the days when a PC was a 400-pound screen and a couple of floppy disks. That's not what PCs are anymore. And if you think about the logic and all this, right, it's kind of funny to me. When virtualization first came out, the whole goal of virtualization was to make it identical to a physical machine so that there was no drawback. Now that virtualization's accepted and people go, it's not a bad thing, we might actually use it a little while. Now it's, okay, how can we take advantage of the fact that it's virtualized and get something better because it's virtualized? And that's where this idea of a Gen 2 VM came from. Now, to create a Gen 2 or a Gen 1 VM is real simple. And in fact, there's not a whole lot of difference. These right here, by the way, are Gen 2 VMs. Server 1, Server 2. There's nothing any different about them. What's different about them is the hardware that they're based on. If you'll notice in here, there's no BIOS option. If I go look at a Gen 1 VM, which I believe, so this guy right here, this Win client is that's Gen 2. I think I have a Gen 1 here. Nope. We'll make a Gen 1.
Let's do it.
So a new virtual machine. We'll actually do it over here to make it easier to see.
Now, while you created that, one thing that you'll notice that comes up during the wizard is it actually prompts you, do you want to create a Gen 1 or a Gen 2?
Yeah, so,
go ahead.
So there's Gen 1, Gen 1. We'll take the defaults for this one. I'm not too worried about it. So there's your prompt. And this is, by the way, you pick it now, you can never change it.
That's the important thing.
Well, actually, no, not entirely true. I'll get to that in a second. So you pick this now, and you can't come back through this wizard and change it. There's a tool that one of the Hyper-V guys released that will actually convert from Gen 1 to Gen 2 by essentially destroying the VM and recreating a definition using the same VHD. It's not a conversion. It does get it done.
Technically, it's unsupported. So we do want to, kind of caution you on the exam. If you get a question, can you convert? There is no built-in utility that's supported by Microsoft that allows you to do that. But there are third-party and community applications that can let you do that.
So we're just hitting next on this a bunch of times, and we'll come back to this wizard in a second, but I want to show you the difference between G1 and G2. So here's the Gen 1. If I look at the settings on it, it's got the stuff you would expect to find in a PC, BIOS, right? You got memory, IDE controllers, things of that nature. If you look at the Gen 2 is actually based on a UEFI.
Yep, UEFI.
One of those acronyms. UEFI BIOS as opposed to a traditional BIOS. So it's got a firmware configuration in here which does similar things, and it doesn't have IDE. It's only based on SCSI.
So a little more flexibility.
And a Gen 2 VM is generally better because the SCSI bus is generally better than IDE for everything within a VM because they're going to handle transactions better, commits better. So when you can, default to a Gen 2. That's my recommendation. When you can, default to a Gen 2. There's no functional difference other than, it's like buying a newer generation piece of hardware and putting Windows on it. There's nothing any different in how you administer it or manage it or work with it. It can still do everything the same way, but it's just a better architecture in general.
Absolutely. Now, some qualifications around that. You do have to make sure that the guest operating system is still specifically supported for Generation 2.
Correct.
So as you go through and create it, I will give you those options.
Yep.
But another thing that's we're seeing a lot of adoption or a lot of benefits from Gen 2, this fact that they do boot from SCSI. Now, this has been specifically interesting as we started to see people migrate from VMware. Now, VMware virtual machines, they always boot from IDE. Previous Microsoft Hyper-V virtual machines had to boot, they boot from SCSI. Previous Microsoft VMs had to boot from IDE. So as part of the migration process, you actually had to go and update the OS mapping within the VMs. Now using Generation 2 VMs, they can both boot from SCSI, skips that step, and simplifies the migration between the platforms.
So today, 2012 and Windows 8 or later are supported for Gen 2 VMs. So in terms of configuring settings for VMs, as you can see from the wizard that I ran through very, very quickly, you basically go memory, network, disk, done. Right? Generation, memory, network, disk, that's all you pick. Once you create the VM, by the way, if you do it through PowerShell, you can specify everything. You get really, really granular. Once you're created, that's when you can come in and modify all the different settings of the VM. So for example, the memory, and we'll come back and talk about dynamic memory here in a little bit. Number of processors, let's bump this one to 4 processors. Things like compatibility, the NUMA topology. So if I click Use Hardware Topology, it'll actually go out, interrogate the hardware topology, and pick the best configuration for NUMA. In fact, if I bump this up high enough, it should actually alter itself. Let's take this one all the way to 12 cores. And let's apply that. And so it's still using one socket for the VM. So, okay, let's do that. Yeah, still wants just one. You can manually modify this. There's no reason you would ever do it. So Hyper-V figures out the optimal topology. You can then add additional network adapters, connect network adapters. For example, just adding a network adapter here. And notice we've got options for legacy network adapters, which we'll talk about in a little bit. So add another network adapter connected to another switch, for example, or the same switch I want to do teaming. And then configure things like the integration services. So here's where I would go in and turn on the guest services, which is the enhanced session connection option. And then also configuring things like the checkpoint file location, which is the snapshot location, and also the smart paging file location, which we'll talk about here in just a little bit. So these are your basic hardware settings. And then again, this is all exposed under VMM with actually a little more detail. And you can create profiles which are collections of these settings. So when you create a VM, you don't got to go configure all these settings. You just go create a VM and apply the high performance VM profile, which says 4 procs, 16 gigs of RAM, SMB-based storage, and some other things. And so you define all these, and you'll see this when we define all these within VMM. So dynamic memory. This is something that, again, came about around the time of remote FX and was initially targeted at VDI. Okay? So this isn't something that you will typically find on server implementations. This is something you typically find when you're virtualizing client operating systems for VDI, because user usage patterns tend to elevate and decrease a lot. There's a lot of variance in them. It's very easy to predict server resource consumption, right? If you're planning a SQL server, a SharePoint server, an Exchange server, there's tools that will tell you, hey, 20 users doing 100 emails a day, this is what you need, and it will be very consistent. With client operating systems, how much memory the client VMs are using, depends on what the Kardashians are doing at any given point in time. What's trending on Twitter. I don't know. I don't know, but that's the nature of it, right? It's funny. I was actually in, I believe it was Amazon, I think, a number of years ago. There's their social media center where they track all this stuff and they allocate resources based on what the Kardashians are doing, because it depends on determines what people buy, and they have it that precise. It's incredible.
Interesting.
I'm embarrassed to even know that name. I got to admit it. I think I'm leaving right now. So with dynamic memory, what this will do is it will make more efficient use of your RAM by allocating memory up and down as VMs actually need it. So as VMs need more memory, it balloons up. As they no longer need memory, it balloons it back down and allocates it to other resources. So there's a couple of settings in here: startup, minimum, maximum, memory buffer, memory weight. rather than look at the slide, let's look at the actual VM setting for that. Let's take this G1 VM and go under memory here.
Now, one question that you may get asked is around what settings can be modified while a virtual machine is running, what settings cannot be modified while a VM is running. And so that's something that we definitely encourage you to spend a lot of time on. You are going to get asked that. Now, if you want to modify the static memory, not possible. Can't modify dynamic memory settings when it's running. But the dynamic memory itself will adjust on the fly.
You can modify the weight while it's running.
Okay.
So startup RAM is how much RAM you give the VM when it boots. Minimum RAM is how much it needs to operate. And there's a scenario where startup might be higher than minimum, which is you need a lot more memory to actually get the VM booted than it needs while it's up and running.
And that's to like load drivers, connect TCP IP, all of that stuff.
Pretty common, to be quite honest. The max is, how high will you let the RAM actually go?
Now that looks larger than you maybe even have on that host. Why is that?
It just defaults to as much as it'll put in there. I don't know why it's that number, but
that's actually exactly one terabyte of RAM. That's what that number translates to with the binaries. But essentially, what we try to do with the virtual machines is, by default, give you the max. And if that host can use it, if that VM, that host has free resources, we'll go max it out. We'll make that VM run as fast as possible on the host.
The buffer is, here's what the buffer does. So as the VM boots and it begins to use RAM, once it reaches less than 20% of available memory, it will add 20%. So that's where this buffer value comes in. So it'll always maintain 20%, and it will do it in increments of whatever the buffer value is. So if you have a gig of RAM, you take it to 800 meg, it's less than 20%, it'll bump the VM to 1200. You can go up, once you hit 1,000, it bumps it another 20%. It just keeps going up. And the weight is, if you have more than one VM, how it chooses which VMs get RAM if there's not enough and they all want some.
So some basic level of prioritization.
Yeah, exactly. So the real important VMs get higher weight, the less get lower weight. It's real simple, real easy to configure, and it's native within Windows. There's nothing you've got to do. As soon as you configure this here, the operating systems actually take care of it. The only weird sort of thing is that Task Manager in Windows actually shows the high watermark until you do a reboot. And so at some point, I'm sure that'll get tied up. It doesn't really matter, but it actually shows, the VM will go down, but Task Manager doesn't go down with the VM, unfortunately. So just be aware of that, and you'll typically be fine. So here's kind of a little sort of animated example of this to help get the point across. So at 15 minutes in, you can see that we've started at all about a 1 gig. As people have been using the VMs, it's adjusted the memory dynamically. Now we bring in another VM and change the weighting around, and you can see that it's now lowered some of them as one VM has wanted more memory. And so this is, essentially what would happen as you work through that scenario.
And so based on those maximum settings, though, you can, in theory, overcommit memory on a host because, while it can bump up to those maximums, that'll be supported. You can't overcommit the minimum memory, though, on a host.
And the thing is, it's all about capacity planning and just kind of playing the averages. You're gambling a little bit by saying, what, I need, I have 100 users to support on the server. Each new user needs 2 gigs of RAM. That's, 200 gigs of memory, but they're going to average maybe 1 gig. So,
128 might work.
Yeah, exactly. And you kind of, figure out that best cost balance. And it's all based on, it'll kind of based on timing as well. These guys need it in the morning, these guys need it in the afternoon. And then you block Facebook. Smart paging. Smart paging is a technique that's used to ensure that in a scenario when you have dynamic memory, when you have the startup RAM bigger than the minimum, that you can still boot, right? So let's say that you've got your memory is so committed that you want to boot a VM that needs 3 gigs to boot, but there's only 1 gig left and its minimum is 512. You can still boot that VM because it will actually do an additional level of what's effectively a page file to allow the boot to happen. It'll be slower, but it will boot, and then hopefully after boot settle down into running an actual memory. So it's a technique to allow virtual machines to boot when the amount of memory they need for startup is not available. That's what smart paging is. And it uses basically a page file on disk. And
so basically what you're saying is we're temporarily creating more memory, but rather than doing that in the memory itself, we're actually doing it on disk and kind of simulating
that. You're doing, but it's basically a page file.
And then as soon as that memory gets freed up, we will actually, take it out of the page file, put it back into fast, real memory so that you can continue using it as a normal virtual machine.
Absolutely. Next piece here is the integration services. The integration services, we kind of alluded to a little bit already, are something that we don't really have to worry about anymore, to be quite honest. Back when Hyper-V first came out, because it wasn't released with Windows, it was released a little bit later than Windows, people would make VMs and the performance would be horrible because they didn't add integration components. Integration components are basically drivers. So VM additions, VM integration components, what does VMware call them?
They call them VM tools.
VM tools, there you go. Are just the drivers you add in to make the operating system virtualization aware. Now, the cool thing with Windows is they're there by default, starting with 2008 R2 and Windows 7. They're just in there already. I think it might have been Vista SP1 even where they started including them.
It's been a while.
Yeah,
but one of the more interesting investments Microsoft's been making recently is investment around Linux and open source. Yeah. So you've actually built up an entire open source Linux team. They contribute to the Linux kernel, so the actual open source project. And now we actually include our integration components directly in the Linux kernel. So if you get a Linux distribution, CentOS, Ubuntu, SUSE, Red Hat, any of those that are built based on those Linux distributions, those integration components come out of the box. So you just
already there.
Boot the operating system, it knows it's running inside a VM, and then you can do things such as live migrate those VMs, do backup using Data Protection Manager with consistency, and even take advantage of dynamic memory for those Linux virtual machines.
So dynamic memory for Linux is actually a pretty significant thing. That's fairly new as well. And
brand new, yep.
Yeah. And that's great. It applies there as well. And then you'll see within the VM there's some services that run, and then on the VM itself you can actually control some of these integration components just under the settings under integration services. And to be quite frank, there's not a whole lot of reason you would ever disable any of these in production scenarios. There's not a whole lot of real good reasons. But the only one you might want to disable is time synchronization. The reason for that is what this does is when the VM boots or when you save it or apply a snapshot, it syncs the time with the host and keeps the time of the VM synchronized with the underlying host operating system.
Yeah.
If you're using an external time source and you want to make sure all your assorted operating systems and VMs are using the time source as opposed to the host they're running on as the source of time, you turn this off and point it at the time source. And that's the only real fairly common, I guess, I don't really know how common it is, but sort of legitimate kind of production scenario for turning off one of those integration components.
Now, the other time that we use that host integration components on is actually when we do some development testing. And we want to kind of always roll back to a specific set of time so that we could kind of see active items in the logs, in Event Viewer, in perfmon. So by disabling that host time synchronization, and having a snapshot, you can roll back to the snapshot. The host does not sync to the current time, and so you can kind of simulate still living in the past, being frozen in a previous point in time. So that's kind of the only time I've used that.
Yeah, absolutely. So in terms of, we mentioned storage and ways of attaching storage to VMs. You have now a virtual fiber channel adapter. And this is a pretty significant addition because what it enables you to do is directly attach fiber channel storage to individual VMs. So you actually have a virtual HBA that you can connect. Now, to kind of show you where this goes, I can't do it because I don't have a HBA. But if we go add hardware, we can add a fiber channel adapter, and then it will you actually define virtual SANs, and you can connect the fiber channel adapter to a virtual SAN, and it has the same worldwide names, which are fiber channel for MAC address. That you would see when you do real, honest-to-God, physical HBA configuration. So if I go up under Virtual SAN Manager, I can actually create a fiber channel SAN. Left the default name. Under the VM, I believe I had cancel on that before, so we'll add the fiber channel adapter. Connected to the fiber channel SAN. And away we go. But the problem right now is there's no host bus adapter in the machine, so I can't legitimately complete the configuration, but that's really all you do. You then take these worldwide names that you can edit, you can modify, and your fiber channel SAN, so if you have an actual host bus adapter card in there, your VM will now appear as a host on your SAN, and your SAN can now be made available to your VM. In order for this to work completely across the board. There are certain fiber channel adapters you have to use. They have to support a function, which I forget the name of, unfortunately, that relates to virtual fiber channel. But if you go in and you look up the Windows hardware catalog, I want a fiber channel adapter that supports a virtual HBA. There's just a series of functions that adapter has to support. If it does, it can pass those calls through to the VM, and the VM can be on the fiber channel SAN. And what's neat is you can still live migrate the VM, and it won't drop the fiber connection. So we can actually migrate from one host to another onto a completely different HBA, but the VM will not lose its connection to the SAN because the worldwide names go with it.
Great. And we're actually seeing a lot of people using guest clustering taking advantage of this fiber channel, because fiber channel, whether it's on a physical server or connected to a VM, can still be shared, give you distributed access. So whether you want to go and use iSCSI for your guest clustering, a shared VHDX file, or use fiber channel, these are now all supported for your guest virtual machines.
And the reality of it is that most IT organizations that have made an investment in fiber channel, they hear me say, fiber channel is kind of hard, and they kind of go, no, it's not. I know how to do it. Yes, they know how to do it. They've invested in it. It's not hard for them, and so this is a godsend.
Highly recommended. Yep. Yeah. No reason not to use this.
Because we tell them, hey, you can plumb fiber channel to a VM. They go, okay, cool, no problem. Do it all the time. So it becomes another option for guest clustering. And I know, for scenarios like SQL and whatnot, where they want really, really fast, like fastest possible disk throughput, this is the way to go. So fiber right to the VM, you can still get the benefits of being a virtual machine. So huge move forward.
Great. Well, let's move on to our next section and talk a little more about installing and importing virtual machines.
So when we talk about installation, what we're really talking about is how do I get an operating system in the VM? And this isn't rocket science. You install the operating system, right? CD, DVD, ISO file, to Pixie boot it, doesn't matter. But you can also do what I think is pretty cool, which is the what used to be Wim to VHD and is now called Convert VM Image, I think. So there's a PowerShell commandlet that you can go download off of Coplex that you basically point it at an WIM file. So you take like your Windows installation ISO file and you extract it, which Windows supports now natively. Get the install.wim file, point this tool at it, and it makes a VHD for you.
Very nice.
And it can be VHD, VHDX. It can be 10 gigs, 20 gigs, 1,000 gigs. And you just make a VM off that VHD file. And that's done the effect of installing your operating system for you. So installing VMs, the operating system, piece of cake. VMM makes it even easier because you just go, hey, this VM, that host, that operating system, go. And it's got everything it needs ready to go. And you'll be showing some of that tomorrow.
Yep.
Importing. Ooh, something near and dear to my heart. Best way to tackle this actually is this. There's been a lot of changes on this front, okay? The first thing is, with 2012 and 2012 R2, you no longer have to export VMs, okay? With 2008, if you've used it, in order to get a VM from one host to another, you had to export it. We made a copy of all the hard drives, which was a lot of I/O, then you copy all those files over, and then you import them. And the import, if there was anything out of whack, if there was files that had moved around, or there was an ISO file missing, it'd fail. And it was not the best of experiences. And there was an API where you could fix all that, but it was an API. And Microsoft recognized that this is a pain point. So what they've now done is you can just take the files from a VM, and you can just copy them and do what is the equivalent of a registration. And so for those of you that are intimately familiar with this, you may have noticed in the past there was these .exp files and config.xml. They're no longer there. You now just, an imported folder structure and an exported folder structure are identical. And if you just copy the files, you can register them. So it's a huge step forward to make this simple. And the UI now figures out all the things that might be broken, or might be messed up when as paths change and whatnot. And switch names change, and prompts you to fix those as you do the import. Virtualizing a physical machine. I know there's a bit of a sore point here because there's the notion of P2V conversion, right? Physical to virtual conversion. System Center supported that in the previous release. This release, it actually doesn't support that anymore. Hyper-V doesn't include native P2V functionality. So there's a couple of ways that you can actually do a physical to virtual conversion. And one of them is using a tool called Disk to VHD, which is a sysinternals tool. It looks like this.
We'll go post that link.
looks like this right here. You point it at a drive on a machine. It takes a snapshot of the drive, makes a VHD, and you can then boot that into a VM. Now, having done this a couple of times, about the only real annoyance to this process is you've got to deal with all the driver changes. So you boot it, detects a bunch of drivers, you reboot it a couple of times, but generally it works pretty well. In terms of application, we've kind of covered this a little bit already, so we're not going to spend a great deal of time. The way that you interact with a VM interactively on the host is through virtual machine or VM Connect. VM Connect is this application right here that I'm running right now. It's native on part of the RSet tools, part of Hyper-V. Double-click a VM. This is what comes up. Runs on port 2179 and just does an RDP connection into the VM. The enhanced session mode, I believe we've kind of covered this already, so I'm not going to cover it again in the interest of time. But as we mentioned before, available for 2012 R2, gives you RDP level access in the console session, regardless of the network.
All right, so let's talk about checkpoints.
All right, so checkpoints are the equivalent of snapshots. Now, simplest way to do this is to do some examples of them.
Okay,
right?
let's do it.
So first of all, a snapshot is basically a point in time on the VM that you can roll back to. So for example, this VM is running right now. I can take a snapshot of it. So I right-click it, click checkpoint. And so what this will actually do, you can see it right here, create the checkpoint. So I now have a point in time at the 19th at 12:11 p.m. where I have a freeze frame of that VM. I can continue to work, I can make a bunch of changes, and I can roll back to that state. So for example, if I open up this VM, which is right here, and I go, well, let's take this folder and let's just do something like, let's make a new one. Make a new bitmap image right there. So I've made a modification to the VM. And I go, you know what? Didn't quite work out. I can now go back and apply this checkpoint. By applying that checkpoint, I'm saying this is the version of the VM that I want to be made active. And it's going to prompt me and say, hey, you're going to apply this checkpoint. If you do, the way it is now is going to get removed. So do you want to take another checkpoint, or do you just want to apply it? And I'm going to choose create checkpoint and apply just to show you what it does. You'll see a bunch of stuff happening up here as it does the work. And so now I've got, you see kind of structured around, my VM roll back to the point where I didn't have, I'm just going to reconnect to it, or I didn't have that bitmap on the desktop. Oop, let's drop that screen resolution all the way down to super small. So there we go. So it's back to that point in time where there was no bitmap on the desktop. But I've also now got an additional point in time, and I can actually rename this, or have the bitmap on the desktop. And so I can now move that VM essentially back in time and forward in time as I work with additional configurations of it. This is great for dev, for testing. If you're working through, you're building a server, and you're maybe not sure if you're doing it the right way, you can take snapshots at points in time of the build, and if you get to a point you go, oh man, I screwed that up, rather than trying to uninstall the application, which maybe doesn't always go as well as you would like, you can just revert to the previous snapshot, and it's as if it never even happened.
Right. I've been using this actually through demo type environments to kind of show different states of a system. So, Corey and I have been working together to build a lot of Windows Server systems set to demos. And we constantly want to say, hey, we just need to show demo 3 out of these 10. And so by using these checkpoints and taking them serially as we're building up this infrastructure, it allows us to move not just back in time, but also forward in time and really jump between these different states to really show a dynamic infrastructure.
Now, where checkpoints can get confusing for the uninitiated is deleting versus applying, because it's not as straightforward as you might think it is. For example, if I apply a snapshot, I'm deleting changes. If I delete a snapshot, I'm saving my work. And so it's a bit of a confusing concept. So let me try to explain this a little bit here. I've got this bitmap on desktop right now. That represents a state. If I were to delete that snapshot, what that's going to do is merge the changes of that snapshot up one level. So I'm basically saying I want to keep, by deleting a snapshot, you're saying you want to keep all the work. By applying a snapshot, you're saying you want to discard everything but this current state in time. And you can create, very complex. I can create snapshots up here, so I can apply this one.
Different trees, different
trees, and you can have multiple levels in very complex snapshot environments. Take the time to learn how to do this before you start doing it en masse, because inevitably you'll delete something you meant to keep or keep something you meant to delete. So you've got to get your head around the terminology for it. Now let me kind of show you an example of what happens sort of at the file level. So here's an example in this whole screenshot of what I was talking about before: adapter patches, applications changes, kind of showing what that might look like for the process of maybe building out a server, for example. Now what snapshots are actually doing at the file level is creating differencing disks. So when you create a snapshot, we talked about diffs and bases a little while ago, it's actually creating a differencing disk. And that differencing disk contains all the changes from this point in time forward. And when you delete the snapshot, the differencing disk is merged back. When you apply it, the differencing disk is deleted and a new one is started over. So you got to think of it as how things were at a particular point in time. So here's an example of what happens at the file level. I want you to focus on not the stuff on the, I guess what would be the right-hand side, but the stuff on the left, which is a very much simpler example. So we take a snapshot. The snapshot was taken with that little red dotted line. Now we've got the changes that are being captured in the what's called the AVHD file, or the AutoVHD, which is the snapshot. Take another snapshot, and you now get another VHD file. So you're creating this tree. Okay. So if you were to apply the snapshot at this point right here, what you're saying is how the machine was at this point in time, which is everything from here backwards. So everything from here, there we go. Everything from here backwards is what you want to keep. All this stuff up here goes away. So that's why apply is delete, essentially. Delete everything from this point forward. Now, what that does, basically deletes the AVHD, recreates a new one. If you were to delete a snapshot, so let's say I delete this one back here, you're saying, I no longer want the ability to go to this point in time. You're not saying delete the files, you're saying delete the ability to go to this point in time. And when you do that, remove this point in time right here, all these changes become permanent and merge. So it looks like this.
And you'll actually see a merge operation displayed in Hyper-V.
And that can be done while the VMs are running, which is new and cool. So exporting, first of all, you don't need to do it anymore, but you can do exports of VMs. When you do an export of a VM, it creates a really nice little package of files, very structured, very neat, very tidy. I love them. But you can export a VM while it's running, and you can export a snapshot. So if you export a snapshot, it's going to take all the related differencing disks, merge them so you get one VHD as the output of the snapshot, and when you import the VM on the downstream system, there's no snapshots. It's that state of the VM. So, talked about snapshots, when should you use them? Well, first of all, you only use them dev test, use them in isolation, and if you have an infrastructure, like for example, you said you're building some demo environments that can, presumably contain more than one server, you always apply and delete the group. You never do individual servers because they get out of sync. For example, let's say that I join a domain, right? There's a domain password that happens, and I revert the VM, I revert the domain controller, but not the client. The client still thinks it's domain joined. The VM doesn't know what the client is, so there's a disconnect and it's broken. That can get really, really, really ugly in production environments. So look at this example here. This is why you never checkpoint a domain controller. Well, there's a fix for it now. So here's a domain controller, right? And what we're looking at here is what happens when we create users. So I create a checkpoint at a particular point in time. Pay attention to, in this example here, the RID pool and the USN. So pay attention to these guys right here.
And what are the RID pool and the USN?
The numbers used to generate the SID for the user accounts that are created. So I create 100 users. The RID pool has now been advanced, so I've used some of them. I've made 100 updates to Active Directory, so the update sequence number right here has gone up and the RID pool has gone up. And I then replicate that to my second domain controller. So it's now identical to domain controller 1. I then go, oops, I didn't mean to make those users. I'll just revert the checkpoint. Really simple way of doing it. Well, look, it's gone back to 100. The RID pool's gone back to 500. However, this guy still thinks it's 200. He still thinks there's a bunch of users out there. So I create another 150 users to get it right this time. Advances, advances, but again, there's a disconnect right here. The result of that is we have 50 users replicated. There's a bunch of duplicates. The RID pool's all messed up. You have conflicting SIDs, and you're spending Saturday night restoring Active Directory.
Fun.
So, people did this in production. And, Microsoft Tech Support had dozens and dozens, if not hundreds of billions of millions of calls about, replications broken in AD. Well, did you checkpoint your domain controllers? Well, yeah. Well, that's why. So Microsoft introduced something called VM Generation ID, right? This is a way for a domain controller to be supported for scenarios where you're using checkpoints and snapshots. And here's basically what it does. So first of all, it's a 64-bit integer, basically a GUID, that is tied to the VM configuration. And it's used to identify when an action has taken place on a host that has the potential to move the VM forward or backward in time. That's the key. And so these would include things like save states, snapshots, import-exports. So something that has the ability to take a domain controller and change its time forward or backward. And it's that change of time forward or backward that causes potential replication issues. And so if it detects that there was possibly a change in time forward or backward, it immediately assumes that it's wrong and tries to essentially sync up with all the other domain controllers that it assumes are correct. And so by doing that, it protects itself from that scenario that I just described. There's a component called the Hyper-V generation counter. There's a GUID stored on the domain controller's Active Directory object, which represents this. And it's also stored in the XML configuration file of the VM definition. If you were to look in the event log when you apply a snapshot or a checkpoint, you'll see an entry like this. A generation ID change has been detected. And what that means is you performed an action on Hyper-V that has the potential to change the time of a domain controller. Hyper-V then changes the GUID in the config file of the VM. The domain controller, the service in the domain controller, this guy right here, detects that the config file's got so it passes the GUID via memory into the domain controller. It detects that, wait a minute, the one that I had and the one that's on the host are different. Therefore, something happened on the host to change time. I'm immediately going to assume I'm wrong. I'm going to inbound replicate from everybody else. I'm not going to accept any new objects until I inbound replicate. And once that's all done, I'll be happy. And so it prevents that bad scenario from happening again. So that's that.
So what are some of the ways that we can, just make sure that our hosts and our VMs are monitored?
Well, this is going to be pretty simple stuff. So we'll kind of end this on a lighter sort of piece of information. But performance monitoring is what it is. It's pretty straightforward, and people generally know how to do it. And the fact that it's you're monitoring VMs doesn't fundamentally change anything, but you have to realize that you're no longer monitoring a 100% isolated environment that you control. There's other things that you maybe can't see that are impacting it. So first of all, we know what performance monitoring is. Yay, cool. Tools you have available to you, Task Manager. Might seem trivial. This is probably my favorite tool for performance monitoring. That whenever someone says, hey, there's a performance issue on either a server or in a VM, this is the first place you go. And what you're looking at is that performance tab and the applications to go, what's using memory, what's using disk. And usually, after I stop here, step 2 is this guy. So if I go I'm just going to grab this guy real quick on a host here. So I grab Task Manager. And if you're dealing with a little more advanced server, you can go, let's look at NUMA nodes to see how the sockets are being utilized. Change graph to logical processors, those are being utilized. One of the real neat things, by the way, is if you're dealing with, and I've seen this on some of the original generation 10 gig network cards that we bought, they were single socket. So they would do offloading of 10 gig, but they'd hammer one socket only. And so we go in there and go, why is the CPU performance what it is? And you'd see one NUMA node, which is one socket, pegged at 100%, the other at 0. So you're not getting you're getting the performance of one socket out of that machine. And so you get to see these things just here in Performance Monitor to see exactly where the performance is being used. And you should see, equal performance across all the sockets, i.e. the NUMA nodes. And then on the resource monitor, which is typically your next step, you go, okay, quick overview, what's using memory, and I'm typically looking at what's the working set of memory for any given process. I'm typically looking at the network utilization to see what services are doing the most network input-output. So I just look at total, and then the same thing with disk. What is actually using the most disk within a VM or on the host? Now, looking at the host will not tell you what's going on inside the VMs. So that's where you start looking at individually within individual VMs to see what they're doing. But this tool here, in my mind, is very often overlooked because there is a wealth of resources available. So you can see how memory's been broken up, how disk is being broken up, and I love this view right here for disk. Just looking at the queue length, right? What's the current, what's the lag on disk I/O right now? And if this is low, we're good. If it's high, we're bad. And then finally, your event viewer, which everyone is pretty intimately familiar with by now. But Hyper-V has within, and I think few people are aware of this. So we're just looking at event viewer. There's actually an entire subset of events dedicated to Hyper-V under server roles. So this is focused explicitly on Hyper-V, so system level events that are generated by the Hyper-V role, but then also under Windows logs. Sorry, application service logs, Microsoft, Windows. And we start digging down in here. Hyper-V config, Hyper-V VMS. So this is the management service. So this is where you see things like, are VMs booting? Do VMs have, adapters? What's the, have I created things, modified things? And then you can also, with these guys, under view, there's an analytic and debug log option, which gives you
more advanced,
nauseating detail.
A lot more data.
Yeah, it's performance impacting data. But if you're in an advanced troubleshooting scenario, it's valuable
the trade-off
data.
You need.
It's valuable data.
Now, a good best practice related to the exam here is just kind of get a brief understanding of what each of those different Hyper-V event logs are used for. For example, you might have a question that says, hey, you're noticing a lot of disk I/O, where should you go to troubleshoot that? And then you could kind of look at those tools we mentioned here, Task Manager, Resource Monitor, Performance Monitor, and then the event logs to try to drill down.
Yeah, Task Manager gives you virtually nothing for disk, which is, on the client, it has a nice little disk tracking tool. I don't know why that's not in the server. It's
interesting.
It's, I can show you right here.
That.
On the server, you've got, under Task Manager, you've got, CPU memory Ethernet. On the client, under Task Manager, more details, you get disk.
Look at that. Well, my assumption with zero knowledge behind it would be that on a server you're using SAN storage more so you still got local disk
server,
though, right?
I would care about that on a server more than on a client.
That's true, you would.
And it's very useful because it tells you average response time milliseconds, activity, and then the read and write speed, which tells you how much you're pushing through your storage. So this is very, very valuable.
So maybe you called out a good point there. If you're looking for local disk stuff, you would not use Task Manager. You would go and use one of those other tools for server.
Indeed. And then finally, the reliability monitor, which you can access through Task Manager as well, shows you things like when patches were installed. So you can kind of go back and go, well, what's changed? That's, server was doing well. Now it's not what's changed. Well, this can show you potentially, what it was that was changed. And then, of course, your traditional performance monitor. And then finally, this is new for, there we go. This is new for Server 2012 R2, resource metering. Now, resource metering is a way of measuring the I/O of a VM for memory, disk, and network for the purpose, it was basically for the purpose of chargeback. So if you were looking at, okay, what does it cost me to run a VM so I can charge back to either a tenant, a customer, a department, a cost center, it gives you a tool to calculate that. Now, this is very rudimentary. It has the framework to capture the data, but the reality is the captured data is almost of no use within PowerShell. There's no way you can get at this. When it's bubbled up into things like Service Manager, that's where the data is actually turned into actionable information that you can make decisions with. But to do it, it's actually quite trivial. If I have a couple of VMs running here on this node, let's do this. We can do a git VM. You can see this VM has a couple of nodes on it. Or this node has a couple of VMs running on it, and let's do an admin PowerShell, which is what I need. So those are the two VMs, and I can just enable VM resource metering. And it's a per VM setting. I just turned it on for all VMs. And then after they've run for a while, I can come in here and go measure VM. There we go. So it measured, I know I didn't measure the first one, but I measured the second one for me. So you can see that it's got an average CPU megahertz, average RAM, new RAM, min RAM, total disk, network inbound megabits per second, total network outbound megabits per second, and total disk disk size. So it's the basis for, chargeback. So as over time you collect this data, the data is stored with the VM. So it actually moves with the VM, but you can then capture this data, use it for a chargeback solution, feed it into things like Service Manager, and go from there.
Great. Excellent. Well, anything else on this module?
No, that pretty much concludes it. That was a big one.
That was a big one. So in summary, we kind of covered the basics of creating your VMs, managing them, testing them for performance. And with our next module that we're going to return to in about 1 hour's time, we're going to go basically take a look at how we manage our networks, do network virtualization, and really make sure that our VMs can go and connect to other hosts, to each other, and to our outside world. We'll see you in an hour.